Okay, fabulous sixth graders. So today we're going to be taking our notes on page 19. We're going to be talking about polygons in the coordinate plane. Today's the 13th. Some of you will be taking it on the 14th. You were provided with an orange foldable that you will need. You're going to need glue. Potentially need a stapler. If you don't have a stapler, you can wait till you get into class to staple it together, or you can figure out how to glue it together. Totally up to you. But we're going to go ahead and get started. So we're going to turn to the next available right and left side page thinking. Remember, you can pause the video at any time as you need it. So we're going to turn right past page 18 of our notes. 18 we did area and perimeter. So note that we're not done with area and perimeter. We're just going to kind of continue on with it. So we're on page 19. Write a 19 in the bottom right hand corner. Going to put our date 10/13. 2020. Okay. So, polygons in the coordinate plane. Almost ran out of room there. Okay, so we have our handy dandy objective. So I can utilize my knowledge of coordinate grids ordered pairs, polygons, area, and perimeter in order to work with polygons in the coordinate plane okay. The other thing that this has to do with is the distance in the coordinate plane that we were talking about. Okay, so distance is a biggie here. So when you're finished with that, I need you to take your handy dandy foldable that looks like this. Okay, notice it has a line here. I want you to cut along that line. And so now you have two pieces. Okay, the first thing that you're going to do is I want you to take we're going to fold this along the top here where it's nice and neat. That way it doesn't cut off anything up here either. So the next thing that we're going to do is this page that's folded this way, you're going to take and you're going to put that vocabulary term right above the perimeter and you're going to fold. And so notice how it looks there. You've got vocabulary, you've got perimeter, and you've got this stuff on the inside. So then we have these that look like this. I'm now going to slide this right here inside there. If I need to adjust it a little bit, I can. I'm going to adjust this one just a touch. Okay, so when I'm done, it looks like this. This is my finished product. If you have a stapler, now would be the time to take and just put two staples, the very, 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 very top, And what it does is it just holds your little foldable together. Okay? If you don't have staples, I'm sure that you can place a little bit of glue there in the top of that one that we just pasted in there, and it'll hold it together, but I wouldn't paste it in until after you're done writing in it. So here we go. Excuse me. Polygons in the coordinate plane. Well, the very first thing that we're going to start with, of course, is vocabulary. Okay? It's our vocabulary. Whoops. That'll drive me crazy. So we're going to start with a polygon is. So we're going to talk about a polygon. So a polygon is a closed figure formed by 3 or more line segments that meet at their endpoints. And that is a 0, or an O, excuse me. So it is a closed figure formed by 3 or more line segments that meet at their endpoints. So we're going to draw a few pictures of polygons, some examples and some non-examples. So one example. So is that a closed figure? Does it have at least 3 line segments? Yes, it's got 4. And they meet at their endpoints, which are their vertices. Here's another one. There's another one. Is that one? No, that's not one. It has curved edges. Doesn't have line segments. This is another example. Okay, that is not a polygon. That's actually 2 polygons put together. Okay, 2 polygons put together. So here's our examples of our polygons. So next, let's look at what a vertex is. This is the point where 2 sides of a polygon meet. Okay, so if we have a parallelogram here, that there is a vertex. More than one vertex is called a vertice. Okay? You can use ordered pairs to represent a vertex. So you can use ordered pairs to represent a vertex in the coordinate plane. So we're going to put this other, the plural for vertex is vertices. Never know when Miss Lewis might make you do a flip grid. Okay. So next, we're going to open it up. Okay, so we're on perimeter. This is 1 perimeter, 2 perimeter. So number 1 says the vertices of a polygon are at -1, 3. So I go -1 on the x-axis, and I'm going to go +3, so I'm going up 3, 1, 2, 3. So this is vertex A, and I'm going to label it vertex A. It says B is at 6 and 3, so 1, 2, 3, 4, 5, 6, up 3, 1, 2, 3. So here is B. Notice the distance between A and B. What is the distance? Well, I could count it. I could say, okay, 1, 2, 3, 4, 5, 6, 7. But something else I understand too is they're in 2 different quadrants. So I would add, and so this one is 6 and this one's 1, the absolute values of them. So 6 plus 1 is 7. So remember, distance on a coordinate plane. So then it says point C is at 6, -2. So I've got 1, 2, 3, 4, 5, 6, and then -2, 1, 2. So here's C. What's the distance between B and C? Well, they're in 2 different quadrants, so we had 3 and 2, so that's 5. So how far do you think point D is going to be from point A? We'll see. So point D is -1, -2, 1, 2. So there's point D. Okay. Says graph the polygon. Tell what type of polygon you have drawn, then find its perimeter. So I'm going to go from A to B, just like we were doing connecting the dots. I'm going to go from B to C, C to D, and that's C to D, and then D back to A. I'm going to close my figure because it's a polygon, so it's a closed figure. So what type of polygon do we have? You're right, we have a rectangle. And it wants the perimeter, so remember the perimeter was to walk around the edges, right? So what I was telling you, we used that information about distance, so we wouldn't even have to graph this polygon in order to solve for our perimeter. But we have it graphed. We could have used -1, 3, and 6 to 3 to figure out what this is. And remember, AB is going to be congruent to DC. So, absolute value of 1, absolute value of 6, they're in 2 different quadrants, so 6 plus 1 is 7. So from A to B is 7 units. Okay, from B to C, once again I'm going to look here, B to C, I've got 6 and 3 and I got 6 and -2, so I'm going to take 3 and 2, 3 plus 2 because they're in 2 different quadrants, so I add, is 5, so from B to C is 5 units. Remember, D to A or A to D is also 5 units because opposite sides are congruent in a rectangle. So, our formula for rectangle was length plus width plus length plus width, or 2 times the length plus 2 times the width, right? So 2 times 7, 14 units, plus 2 times 5 is 10 units. Therefore, we have 24 units as our perimeter. Okay. The next one says the vertices of a regular polygon are blank, 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 blank. Graph the polygon. Tell what type of polygon you have drawn. Then find its perimeter. I would like for you guys, this is kind of a challenge question, but I know you guys can do it. I would like for you guys to come to class and notice they're all in the same quadrant, okay? But I would like for you guys to come to class tomorrow with this one at least graphed, and I want you to at least attempt to find its perimeter, okay? Attempt to find its perimeter. So, that being said, we're going to move on. So we're now on area. Remember, area is squarea. And so we will get rocking and a rolling. So this one says, the vertices of a polygon are J, -3, 2, K, 4, 2, L, 2, -5, and M, -5, -5. Graph the polygon. Tell what type of polygon you have drawn, then find its area. Okay? So, we're going to find J. So we've got -3, 1, 2, 3, +2, 1, 2. So there's J. K is 4, 1, 2, 3, 4, and 2, 1, 2. Okay. See, I'm getting my ordered pairs from here. L is 2, so 1, 2, and then -5, 1, 2, 3, 4, 5. Okay, so that is L. And then M is -5, -5, 1, 2, 3, 4, 5, 2, 3, 4, 5. Now to notice, each vertice is in a different quadrant, and I'm going to have to use a straight edge to draw these lines in here, because they don't follow a straight line, do they? These do, and these do. Okay, so what type of figure is that? It's a parallelogram. So yesterday in our independent practice, we talked about the formula for a parallelogram, and remember, the formula was base times height, because what we could do is, if we look here, I'm going to draw my dotted line here. Remember, my height has to make a 90-degree angle, so I just come over here and I can find my height, correct? But I also can find my base. So notice my height is from K to here. So I go 1, 2, 3, 4, 5, 6, 7 units is the height. Okay, and then here, oh, and I forgot to label this vertice is M. For here I could go 1, 2, 3, 4, 5, 6, 7. So it's again 7 units. So my base is 7 units as well. The other way that I could figure that out is from M to L, guys. So M to L, they're in two different quadrants. Their y coordinates are the same, but their x coordinates are different, so I find the absolute value of 2 and 5, or 2 and -5, excuse me. So it would be 2 and 5. 2 plus 5 is 7. The other thing that I can do is I can look, okay, from K to L on the y coordinates. I can look at the y coordinates, and notice I have because y coordinates are up and down, that's why we know vertical distance. Okay, so I look at my y coordinates. So I've got a 2 and a -5. Absolute value of 2 is 2. Absolute value of -5 is 5. 5 plus 2 is 7, because they are in different quadrants. So I could also find my distance that way, okay, by looking, am I looking for vertical distance, then I look at the y coordinates. Am I looking for horizontal distance, then I look at the x coordinates, okay? So parallelogram, my area is base times height, so I'm just going to do base of 7 units times height of 7 units, which gives me 49 units squared, because remember, area is always units squared. Okay? Okay. Number 4, guys. Same thing. I want you to graph the polygon, tell what type of polygon you have, and then I want you to find its area. So try and find its area before you come into class tomorrow. Okay? That concludes our notes for the day. So what I want you to do is I want you to close it up. Okay? I want you to turn it over, and with your glue, and remember guys, if you have stick glue, please don't use the stick glue because it's not going to stay in. Let's use this other, and if you need some tomorrow, get some. But we're going to use dot, not a lot, of our liquid glue. Boop, 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 boop. I'm going going to get the middle a little bit too. I'm going to close my glue so it doesn't dry up. I'm going to turn my foldable over, and I'm going to paste it in the center of the page right below my objective. And there I have a handy dandy new set of notes. So, today, when you finish this video, I need you to go up to the top right hand corner, and right here I need you to write how long the video was in the top right hand corner upon completion. What was the ending time? See you guys tomorrow.